So our next point is on the unconformity, which I said would mean that there's something missing from the history. So the whole story of the development of the rocks is not complete. How can that be? Now we said that there are like rocks that are deposited, so perhaps we already know that on the bottom there will be something older, on the top younger, maybe originally it should be horizontal as it's layered. Perhaps we also have some of these cross-cutting relationships, so we have other materials that are younger and crossing the older ones. But what can also happen is that all this material that we had here, originally horizontal, perhaps will be in a certain angular position because perhaps it's the development of mountains that often would happen in such a way, for example. So we're just now talking about this little section over there. So what would happen is that the originally horizontal materials will not be found in this position, but it will be something that perhaps it's like bent for certain reasons, tectonical forces, or it's just tilted in an angle. And what would happen often is that a part of this material would be eroded. What does it mean? I'm just drawing here a little like snowflake representing maybe ice. So often like ice, a glacial, so if we think about ice ages, much of the surface was covered by ice at that time. So there would be ice that would erode all this material that was here originally. And what we'd have is a new surface that perhaps again is horizontal, and by time, once this was developed, new deposits are going to cover this surface. And so if we have a kind of image like this, as you see in my slides, what does it mean? It means that there's something here, this surface. It shows that the story is not like continuous. There is a layer here, the red one, which is much younger than what we found here, which is older. And so we're going to ask, what happened here? Why is there a gap? And as a geologist, then you're just going to think that there is a big difference in time. So this is much younger than the one that is much older. So this is just about the unconformity. Students often ask about this one. And I just like to ask in the exam because they're interesting and easy to draw. So you can just draw something like this if I'm asking, what is that at all? And then we would have then the final point, which is, in this case, the correlation. It means that there's some kind of relationship. And how? Perhaps we had different layers, as we said, as we usually have. And here there would be perhaps a fish bone, again dead fish. This is a fish right here. It's dead. Here we have dead snails. There are the layers with similar fossils or remains of animals that we found. And by time, what can happen is that perhaps the water cuts into this one, so there's like a valley that is formed, or even sea or ocean that develops or emerges. And just by finding over here these specific fossils, we will be able to reconstruct the original material, how it was located or where it was located, and we will be able to say that probably because we have the same kind of materials here, they will be of the same age. Now we can also think about how the planet looked like in the past. We have these different continents, Pangea, whatever, and in certain parts of the planet we found similar fossils. And whenever we found the similar kinds of materials here and there, we will say that wherever this is located, whatever like bedrock that is, it will be the same age. So simple, correlation. If we have similar materials here and there, not simple, but similar materials here and there, just that means there's of the same age. So this is then speaking about the 5 principles. And finally, we can have a look at the geological timetable or time scale. And here I'm just going to simplify and speak about one part. So we can have 4 lines that are vertical, one here on the bottom, and then we say that there are super eon, there is eon, then we will have era, period, and finally epoch. So this is how we can think about different lengths of time. And what we have in the very first place is over here for super eon, only this box that we fill in, and that will be then the Precambrian. We don't have anything over here. Precambrian is built up of 3 layers, and first is what we call the Hadean, then the Archean, and Proterozoic. I just make a shortcut here. We don't have anything here, or here, or here. It's not interesting for us. What will be interesting is the eon over here, which is the Phanerozoic. This means that we have visible animals and so on. This is actually Proterozoic, Zoozoic, where we say that there are the ancient forms of life that we know about. And what we will have is the eras over here. The first one is the Paleozoic. Then we have the second one, the Mesozoic, and the Cenozoic. Here there will be, again, different bits that are interesting for us. But now, today, here in this video, I just want to speak about the Paleozoic, which means the old forms of life. And then we can just memorize that here we would have these different layers of periods. First one, the Cambrian. Then Ordovician. After that comes the Silurian, Devonian, after Devonian we have the Carboniferous. And finally, the Permian. So there's 1, 2, 3, 4, 5, 6 periods within the Paleozoic era that we need to memorize. And later on, we will speak about the 3 periods in the Mesozoic and the different periods in the Cenozoic, and especially the epochs, which are also very important. But for the moment, it's just enough for us perhaps to try to memorize this structure. So we had 5 lines or 5 columns, and then we have the Precambrian, Hadean, Archean, Proterozoic eons, 1 year in the Phanerozoic over here, and Paleozoic, Mesozoic, Cenozoic, Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian. We need to know these because many of your biology classes later on will refer to these. So at the moment, let's just try to memorize this one and later on get back to the other part of the table.